our time, 9 o'clock Boston time. And so I bring you to panel one, which deals with integration. And we have a nice, well-rounded international panel for you. We have some new folks and some people who have been with the conference from the very beginning. I'm going to give each of the panelists a few minutes to introduce themselves and tell you a little bit about their presentation. There's now a link in the chat so that you can all access the papers and the presentations. And likely we'll also make Kevin O'Connell's remarks available to you after the fact as well. But with no further ado, let me introduce to you Ruth Stillwell. After Ruth, we'll go right to George Long. Then Dirk-Roger Schmitt can speak, Bibhorr Bibhorr, and we will end with Gustavo Medina. And after that, we'll have a good, robust question and answer session. I invite you all to put your questions and answers into the Q&A part because it's easier for us to manage if they're all in one place. Thanks so much, and take it away, Ruth. Thank you.
Thank you, Diane. The paper I presented for this panel is called Between Air and Space, Can Emerging Concepts in Air Traffic Management for Ultra-High Altitude Uncrewed Aircraft Provide a Model for Orbital Space? So it's a long title. And the reason why it's such a long title is I wanted to give a reader enough of a sense of where we were going. When we talk about range management and integration, air and space, we tend to think about how to get the satellites from the Earth to space and how we get through this managed airspace. But I argue in this paper that there's also something to be learned. And we have an environment that's emerging in the same way as space traffic management of ultra high altitude, unmanned, high endurance vehicles that provide satellite-like services, earth sensing, telecommunications. And these areas are being developed sort of in silos away from one another. So what can we learn by integrating the two? The developments in space traffic management from not only an operational, but also a legal framework with the developments in ultra high altitude unmanned airspace. And the FAA produced this document, the concept of operations for upper E Class E traffic management. You'll find a lot of similarities to STM in there. So my paper presents that. On the website, I have a little video. The paper is available. And during this and also after, I'm available for questions. So thank you for the opportunity to present that here today.
George?
Yes. Good morning, good afternoon, good evening, wherever you happen to be. My name is George Long, and my paper basically concerns that in addition to all the beneficial uses high altitude balloons can provide, there's also some nefarious use that it can be placed to, such as by democratizing the access to space, given the low cost of a high altitude balloon and the development of technology now, the technology can be used to launch or to place small satellites in particular in orbit without following through the necessary governmental regulations and procedures. And that opens a whole new door as to how do states actually supervise access to space if access to space can be achieved without having to go through government regulation. Thank you very much.
Thank you. Dirk-Roger Schmitt?
Hello, my name is Dirk-Roger Schmitt. I'm affiliated with the German Aerospace Center in Braunschweig, Germany, and we are working already for a long time to also to make space flights also happen starting in Europe and also especially in Germany. And so we have different activities already in Germany. Small launcher companies are developing micro launchers also for the international market. We focus especially on a study to investigate how we can operate safely air launch procedures from German airports. And so we made a study for one of the governments of the German states. And in this study, we investigated very in-depth a airport operation by an air launch system. This can be, for example, a Virgin Orbit system, which already they proved they can do it. but maybe also other systems which might be in development. And so we investigated also the flight corridors, the safe areas for air launches. So the mission is that the aircraft will take off at an airfield, military airfield, which is quite close to Peenemünde. And then we'll go over the North Sea, which is a part of the North Atlantic Ocean. And from there, we planned some the launch trajectories. And we found out that these missions are feasible and also very attractive for different interesting orbits, which can be reached from these areas.
Thank you, Dirk-Roger. Bibhorr.
Yeah. Greetings all. I am Bibhorr and I am affiliated to IUBH. I'm an aerospace engineer. My areas of interest are aerodynamics, CFD, and mathematical modeling. So I'll just tell you about my paper. It's about time-matricized triangulation modeling for STM. So in this, I have done a triangulation criteria where for the STM in this space tesselation in 3D dilated coordinate frame we are carrying out. And here basically we are basically identifying vehicular traffic as nodal flux and then rendering of polygon configuration in 3D spatial cuboid. So basically we are managing the traffic using our model for the STM, and then we'll be using this model for fault correction, data gathering, and finalizing the triangulated mapping. So the time matricized modeling of the map data, and then we will be strategizing neighboring traffic movement. So traffic adjustment of the nearby traffic would be done through this model. Yeah, so that is the brief intro of my paper.
Thank you very much. And last but not least, Gustavo. Sir, you're still muted. We need you to unmute yourself. Could you try that again?
Yep.
Ah, here we are.
Sorry, I am in several screens at the same time, so confusing. Traffic management of cursors in the screen. So anyway, so I am in charge of two laboratories in Mexico. One is the Laboratory of Space Instrumentation, and this is located at UNAM in Mexico City. And the other one is a larger facility, a 10-hectare campus near Mexico City at 100 kilometers to the north, where besides developing payloads, small payloads for space, we also launch balloons, and George have expressed several of the advantages of using balloons for testing space technology at a very low cost. Where first we have had experience with large payloads, working with CNES, with zero pressure balloons, and with NASA with super pressure balloons. And at that point, it was this agency that took charge of all the regulation or risk or whatever management had to be done at that point. But when we started with our small payloads and we launch once per month, we discovered that there is actually no regulation in Mexico for that. So we started working just on and we are still in that methodology, dealing on a launch by launch basis, coordinating with the Air Force, with the general direction of civil aviation, which is complicated and in the end doesn't define who is responsible for what. Yeah? It's just management at some point, risk management at some point if you want. So basically the paper we presented is a first study to try to develop assessments of risks, of good norms and everything, discuss also with these main actors that could eventually lead to the presentation of a proposal of legislation to the Congress. Yeah? In particular, in the paper, what we are assessing in this paper is the risk associated with damage on the ground to property and people, and also while we are in flight, because even if it has a lot of advantages of being in the stratosphere, still we have to cross at least twice the troposphere. Yeah? One ascending and one descending, and there you have a risk of interacting with planes or other aircraft. So basically, that's what it is done. And also, the objective is to try to reach, for example, to insurance companies, because another problem is that if we want to propose some kind of insurance for that, or the need for some insurance, when you go to the insurance companies, and we have done it, they just don't know what to say, because they don't know how to evaluate the risk. Therefore, they don't know what is the price they have, the price tag they have to put to such an insurance. So the values we obtain can range over huge margins just because they are covering themselves by orders of magnitude. So these are the kind of problems we are trying to assess, and to try to make a pathway to legislation eventually. Thank you.
Thank you. So very nice summations. Thank you, panelists. So listening to all of you, what strikes me and what's really interesting, as you know, usually this has been like an integration just through the national airspace sort of a panel, and it's evolved. And it's evolved because we're talking about not just integration of a user through a domain to another domain, but we're also talking now about some integration between different kinds of users within a domain, such as like what Ruth was discussing with the high altitude platforms. So my question is, do you, all of you, have any, and in fact, even Bibhorr gave us we have a visual so that we can even see how these domains really differ, and how the activities or the operations are different within them from a visualization standpoint. So do you have any ideas on how to increase the understanding between the different kinds of users within a domain, and then the different kinds of users as they cross domains with the other users in those domains that are like them or not like them? And because we've heard about a couple of different kinds of flight models. For instance, we've talked about the air launch from Dirk, and then Gustavo is talking about something different. So I'm going to put that to we can start with Gustavo, since we still have you up on our video. How you think that we could increase the understanding between users across domain and within domain?
Look, I don't have an answer for that. Is the kind of answer I'm searching for. But I think all start with dialogue, and it is a dialogue we have started a couple of years ago. Because we really need to understand their limitations, even how the other agencies communicate. For example, in our case, we have two airports that are nearby. One is a military airport, the other is a civilian airport, actually is the most important international airport in Mexico. And we have discovered that not always coordination is easy, even between themselves, between these organizations, especially when there are things that get out of the normal, yeah? like a balloon that is crossing the airspace. So basically, really dialogue between the actors, and try to demonstrate quantitatively what is the kind of problem you are posing now to this other space that was working so well before you arrived. so that everything was fine-tuned. Yeah? And also the advantages so that they consider it. But the actual answer, well, at this point, I don't have, and I don't know really what is the best kind of legislation.
And just to clarify, I'm not suggesting that you all have answers. I'm asking if you have ideas. So
yeah.
We'll kind of ramp the pressure down a little bit. Ruth?
Thank you.
Yeah, thanks. I'd like to build on what Gustavo said about dialogue. Because everything was fine until you got here, and which means innovation can be disruptive. But if we have the appropriate information sharing infrastructures, if they have an ability for the operators in a shared domain to understand the needs, uses, and intents of other operators in that domain, particularly of new entrants, then we create a much safer system. And I like to use an example because generally speaking, we have this idea that as long as you and another party you're interacting with know what's going on, it's probably okay. But that's not really true. The other actors in that domain need to understand what's happening. So the example I like to use is that on-orbit servicing looks an awful lot like a hostile act to everyone other than the party who contracted for the service and the party providing the service. So now if we have an environment where you see a satellite heading for another one and you're not engaged in that transaction, Do we create an unnecessary escalation of hostility because of this perception, simply because the non-participants have no idea that the two people participating in that activity have contracted for that service and are perfectly satisfied with it happening? So when we talk about how we know what's going on, that shared information, so that even the non-participants in an activity know what's going on, we can dramatically improve the integration and the safety of the environment itself. So that point that Gustavo made about sharing information and communication is important, but we need to make sure it's not just between a few parties, but across the domain and who needs to know about it. So the information sharing elements is critically important in this integration question.
Thank you. Transparency. George?
I would have to agree and follow up more on Gustavo and Ruth's point, because from my perspective, I'm referring to operators who don't want to be known. We're talking about people who want to place small satellites in orbit without going through the appropriate governmental authorization. And generally, that is only being done by people who you might say want to have bad intent for whatever purpose they want to use it. Whether they're drug lords who want to use satellites to monitor their poppy fields, we don't know. So I agree there has to be great communication between all users, operators, and even governments on this basis, because high altitude balloons operate within the atmosphere, which conceivably which is within the territory of other states. So there has to be a great cross communication that goes on at a governmental level as well as the operator level. Because how else will you be able to locate a spot unauthorized or Maverick small satellites? And then what to do about it. Thank you.
Thank you.
Yeah, if I could chime in on that as well. George makes the excellent point. How do you know what's unauthorized if you don't know the universe of what is authorized? So our ability to identify the unauthorized participants can occur if we don't know who the authorized participants are. So that participation in transparency is important for that as well.
And if I can add a point also in what Ruth said before, it is considering other actors. We have, for example, the problem of the peculiarity that we have to recover our payloads. These things go down to the ground. And we have a huge variety of actors that can receive these things in their property, from companies, regular houses of families, but also aboriginal communities that live in the region. And really, we employ a lot of time to try to educate the people in what these things are, because it can be tremendously stressing to receive something that they think the government is throwing there in their land or things like that. So it's these are problems to be considered, and also to engage the people in this. And that is a kind of activity that differs in that from space. The society is really involved because these things cross the atmosphere, but they land somewhere that is not possible to determine perfectly in advance. So they can go there and arrive to an unexpected place.
Thank you. If Dirk or Bibhorr would like to jump in on this, by all means you can. If you'd like to pass, we do have a couple of interesting questions in our Q&A function. So just raise your hand if you want me to throw this integration question between users and domains to you, Dirk or Bibhorr. And if not, moving on. So Bibhorr, you have interested people greatly with your video, and you have a few questions that are directed towards you. So I'm glad you didn't raise your hand just now. I'm gonna field both of them to you, and you can answer them both or take your choice. In the model that you presented, if a circumjacent polygon is increased, what would that exactly imply? Okay, so I'm gonna park that with you. That means like not a lot to me, so I hope I even gave that the proper inflection. And then by the end of your video, you mentioned data sharing between consecutive nodes, neighbor satellites, within the time-matricized model of the space population. So the question is, are you implying a swarm intelligence-based approach to real-time traffic management in space? So the first question is about the implications of a circumjacent polygon that is increased. And the second question is whether or not you are implying a swarm intelligence-based approach. Thanks.
Yeah. Yeah, so the first is, quite a good question. It is related to the topic. So basically, if the polygon, the circumjacent polygon is increasing in its area, it is actually telling us that the spacecraft under observation is actually safe and its trajectory needs not to be corrected in near future. But if the case was something like its area is decreasing in size, then it would have been the case that spacecraft may encounter collisions in the near future. So if the question is it's increasing, so it means that the spacecraft is not going to encounter any collision. So the flight of the spacecraft is safe. So this would be the answer for it.
Thank you very much.
And
keep going, keep going.
yeah, and for the second question, what was, please, can you repeat it?
This is the question about the swarm-based intelligence. The question, it talks about your video, and I think they might have taken it off since I already said it. Let's see.
You actually, we can inculcate AI parameter in this. So basically, it's since this is a model, we have to start from scratch, being for inculcating it into applications or something like that. So yeah, that is it.
Thank you very much. So the next question is directed toward you, Dirk-Roger, but I think also that Gustavo, you might have something to weigh in on this as well. And so the question to you, Dirk-Roger, is in your study, how is the safety of the surrounding environment? So overflown landmass and traversed airspace, how is that taken into account during the transfer flight, given the special character of the payload of the aircraft? And the part that I think Gustavo might want to weigh in on afterwards is how the character of a payload might influence safety of the surrounding environment. Take it away. I think you need to unmute yourself, Dirk. Going once. Yes.
No, I'm there. Yes, this is a very good question. Of course, but it must be considered that if you deal with rocket launches, the most hazardous area is where the rocket is being launched. So what we did, of course, in our study, we did investigate all the different phases of such an air launch. And of course, we looked in depth through also into the transfer flight from the carrier aircraft, which includes the rocket, which can be maybe even integrated in the cargo bay of the aircraft. But if it's the same system as it is done by Virgin Orbit, it's under wing. And we investigated these transfer flights. These have to be taken over land mass, also in the north of Europe, but there have to be different considerations to be taken. The first consideration is if you fly with a quite inactive rocket, it is not so dangerous. That means also the military is flying with rockets over landmass, over populated areas, and that is not the real dangerous case if you have a certified aircraft carrying the rocket. So the only thing you have to justify and to prove is that the rocket will not ignite and then the rocket will not fall down. So that is quite an easily task to do, to be honest. Anyway, so far we did not work on real regulatory permission to do this. So we made a feasibility study on this and we found this not a real showstopper. The same is valid for the integration into the airspace. So we can use also military airspace, which are available, or temporarily restricted airspaces. This is not, we think this is not a real problem, although I can say we did not really do the regulatory work and for this. If you go then over the sea for the launch, you do it over international waters and also in international airspace, or maybe over German waters. You have to consider the ship traffic and also the other airspace. But this, we believe, can be done how it is also done in other locations when there will be a space launch in Cape Canaveral going eastbound, or a rocket is launched in Kourou. You're also using airspace, and you have to inform the traffic in the airspace, and you also have to inform the ship traffic. There has to be done a lot of work on this, but the transfer flight we consider not the most complicated part.
Thank you. And I don't know, Gustavo, if you have any thing that you want to add about how you, how the special character or a hazardous nature of a payload might impact how you determine safety for the surrounding environment when you're launching. And I further to what you just said, Dirk, I think you're right. Everybody learns from one another. I know that U.S. launch law has been looked at by many around the world for lessons learned. And I think that should help you a lot also, Gustavo. But go ahead.
Yes. Well, first of all, there is a whole range of stratospheric payloads, which, from the point of view of risk, the main factor is mass. So there is some regulation, international regulation, which is the law of the air from ICAO, that you can use as a guideline. My first question is that this is very old. I don't know if it is updated in that sense to new kind of aircraft or things like that. But basically, if you are below 4 kilograms and you respect certain parameters, like you have a column density in your payloads that is not larger than 13.5 grams per square centimeters, or that all your ropes and other attachments break below 230 newtons, in principle, you should not damage an aircraft, at least more than a bird would, a large bird. So that's one thing. But I think that should be assessed. And the other thing is that it lacks a verification mechanism. I go to the first talk at the beginning of believe, but trust, but verify, yeah? Because other actors cannot respect these norms. And since this is the very low end of what stratospheric ballooning means, there are plenty of actors that do them by themselves, and you have to believe that they are following these rules. In any case, when you have a payload of this mass, for example, the probability of hitting a person, at least in our region of interest, is something like 1 order of magnitude below the risk of being hit by a car when crossing a road. But even if it goes on top of the person, the dissipated energy is rather small, something like 100 joules, because we also have aerodynamic brakes besides the parachutes. So these are things that you could put in legislation. In that case, even if the parachute fails, and we have had the chance to verify that, but by hitting a house, which is something that has a larger probability, something like 10 to the minus 3 per flight, we have produced no damage at all, not even to the charge or to the facilities on the ground. Yeah? So there are these kind of things that you can do. And of course, when I say if you hit a person, of course, if the design of the payload is such that it has hard points or things like that, the damage could be larger. So these are things that could be regulated or taken into account, because still is like a Mike Tyson good punch if you receive it. Yeah? But anyway, so there's the kind of things you can do. Thank you.
Thank you. This last question is for you, George, and there's an easy part and a not so easy part of it. It's a two-part question. Are there any international enforceable laws for the disposal of satellites after their terminal life? And if not, can we expect any such laws to pass any time in the near future? So I think this is a chance for you to expound.
I am not aware of any international laws concerning the disposal of satellites, although now a lot of states are enacting legislation to put end-of-life usages into their proposals for licensing. But when we're talking about unauthorized or Maverick satellites, laws really don't matter, because these are people who don't care about the law and have no content or intent to comply with the law, because they want to put up a satellite without following the proper procedure for whatever purpose they may have. How do we deal with that? Or what do we do with those objects once they're found? That's an open question. Maybe that might be a genesis for saying that there has to be mandatory registration of space objects. Because then if there's mandatory registration, then you know what's a better idea of what's authorized and what's unauthorized. And once you find an unauthorized space object, what do you do about it? That's why if you know who the launching state is, then you can get permission from the launching state perhaps to then remove an unauthorized object that was launched from its territory or from its atmosphere. But if you don't know who the launching state is, that's an open question, because the reality is there will always have to be possibly a launching state somewhere at the bottom of the chain under the law as it's now written, which means there is liability for someone with respect to this unauthorized object. So all of those are open questions. And unfortunately, a lot of times they aren't really addressed until we're actually confronted with the situation. But I think that we should actually be a little bit more proactive than reactive, because this is a circumstance that will, in fact, occur. It would be naive to think that unauthorized objects will not be placed in space.
Thank you very much. I think we're out of time. We're at 10:31, and if I'm not mistaken, or 9:31 Austin time. So I really want to thank all the panelists for coming forward, answering questions, putting your presentations together, and we all have the link on how to find them. So let's give you a hand and turn it back over to the organizers. Thank you.
Booyah, booyah. Well, thank you for that awesome Q&A, and you know, all the people in the session. So we're gonna take a quick break, 8 minutes to be more precise, and then when we come back in 8 minutes, we're gonna have our first roundtable, which is gonna be U.S. government roundtable, and it's gonna be moderated by the great Mark Skinner from the Aerospace Corporation. So 8 minutes from now, be back and ready to challenge these folks.